Welcome you all. I am Dr. Nidhi Sharma, Assistant Professor, First Year Engineering Science Department from AISSMS, Institute of Information Technology, Pune. Welcome you all in today's lecture. My today's lecture is based on the conducting polymers. Now, the conducting polymers. Most of the polymers are used for electrical insulation as they are bad conductor of electricity since these polymers do not possess large number of free electrons. So, they do not conduct electricity. So, that's why they are used for the insulation. Conducting polymers have been synthesized within the last several years which possess conductivity comparable to the metals. So conductivity in polymer is observed because of different reasons which include the planarity, conjugation. So according to that, they can be categorized into different categories. So before that, as we know that otherwise normally organic polymers are bad conductor of electricity, but there are few conducting polymers. So how we categorize them? We categorize into three parts. The first is intrinsically conducting polymer, ICP, or conjugated pi electron conducting system is also. So this is the one type of polymer which conduct electricity by its own because of its structural feature. The structure itself possesses some special character due to which that polymer is responsible for the conductivity. So what are the examples? Polyacetylene, polypyrrole, polyaniline, polyparaphenylene. These are the polymers which are conductive. Now, as you can see in the figure, if we talk about the conductivity, if insulator polymer is there, then the conductivity is less than 10 raised to power minus 8. If the polymer is conductor and dope conducting, then its conductivity is more than 10 raised to power 2. But if it is intrinsically conducting polymer, undoped polymer, then its conductivity ranges from 10 raised to power minus 8 to 10 raised to power 2. So, what are the structural requirements for the conducting polymer? The conducting polymers are linear, have high planarity in the structure and possess conjugation. Conjugation means alternate double and single bond in the polymer chain. Now, when electric field is applied, so what happens? The conjugated pi electron delocalized of the polymer and get excited and can be transported throughout the polymer. So increase in conjugation increases the conductivity. Now highly crystalline planar structure is also the requirement for the conductivity. Presence of aromatic rings in the chain with continuous resonance, it also increases the conductivity. These are the few factors which are responsible for the conductance of the polymer. You can see this is the example. This is an example of trans polyacetylene. It is having the conjugated bond, double single bond. Then again polyparaphenylene, there is a presence of aromatic ring. Again there is a resonance. So due to the resonance, the conduction can take place. This is polypyrrole. Here again the presence of lone pair as well as conjugated band bonds. Then polyaniline. So these are the few examples of intrinsic conducting polymer. Now next is the extrinsically conducting polymer. Now extrinsically conducting polymer means these are conducting polymers whose conductivity is achieved by because of externally added ingredients in them. When we are adding some ingredients, then these are the polymers which shows the conductivity. And these extrinsically conducting polymer can be achieved by two ways. First, the conductive element filled polymer. Like if we fill metallic fire, metallic fibers, metallic oxide, carbon black, these can be mixed with the polymer during molding process. So polymer acts as a binder to hold the conducting elements. So conducting plastic containing carbon black find uses in wire cables, anti-static devices, video discs, audio records. Second can be done by blended conducting polymer. It is obtained by blending conducting polymer with conventional polymer physically or chemically. So mainly in two ways. The first what we can do, we can add the conductive element in the polymer. Second, we can mix extrinsically conducting and intrinsically conducting polymers in this way. Now, the third is the doped conducting polymer. What is doped conducting polymer? The ICP, intrinsically conducting polymer, possess the low conductivity, but their conductivity can be improved by creating positive or negative charge on the polymer by oxidation and reduction. So this process is called doping. So that's why these polymers are called doped conducting polymer. So this doping can be done in two ways, p-doping and n-doping. P-doping, which is also known as oxidative doping. So this p-doping or oxidative doping, it includes the doping of intrinsically conducting polymer with a Lewis acid. Either we can add iodine, bromine, FeCl3, PF6, arsenic pentafluoride. These are the examples of p-dopant. So, oxidation means removal of electron takes place on the polymer and positive charge is developed on the polymeric chain. As you can see, when the iodine reacts with polyethylene, then polyacetylene, then it results in the form of polyacetylene with positive charge. So, due to that, the conductivity increases. Positive charge is developed polymer chain. Polymer molecule actually loses the pi electron to halogen atom and iodine molecule attracts electron form I3 minus. The positive charge polyacetylene molecule is radical cation or polymer. So as you can see what happens, how this process takes place, like polyacetylene when it comes in contact of iodine, carbon in presence of carbon tetrachloride, the one electron goes towards the iodine, it forms I3 minus and the positive charge develop on the chain. Now again one more time if the oxidation takes place, so such two positive charge develop on the polymeric chain and this is called solidity. Second type is n-doping or reductive doping. So n-doping, it includes the treating of ICP with Lewis base or with metals like sodium, lithium, potassium, strong metals. So reduction means addition of electron takes place and negative charges develop on the polymeric chain which increases the conductivity. Like this is a metal, it donates the electron to the polyacetylene, the minus charge get developed. So in this way the conductivity increases. Now what are the applications of these conducting polymers? These conducting polymers can be used to make the rechargeable batteries. These have the promising charge storage. These are the promising charge storage batteries. Batteries are small in size, long lasting, produce high current density. These are used as optical filters also. Radiations from computer screen can be absorbed by these conductive polymers. Sensors for measuring pH, oxygen, NO2, SO2, ammonia, glucose, trioxide, oxidized polyacetylene used as a sensor to measure glucose concentration and various other applications. In electronics, it is used as a LED, data storage, light emitting wallpapers, photovoltaic cell and telecommunication system, it is also used. So this is how polyacetylene form when acetylene in presence of Ziegler-Natta catalyst at minus 78 degrees centigrade, it undergoes polymerization, it forms cis polyacetylene. If the same cis polyacetylene is heated at 200 degrees centigrade, it forms trans polyacetylene. Now this is the order of conductivity. As you can see, the doped acetylene conductivity is 400 Siemens per centimeter. For trans, it is less than doped but more than cis. So it means the structure of the molecule also makes a very important, play a very important role in the conductivity. Now what is the application of polyacetylene? The polyacetylene is used as electric wiring or electrode material in lightweight rechargeable batteries, and triiodide oxidized polyacetylene can be used as sensor to measure glucose concentration. These are the major uses of polyacetylene. Thank you all. Thank you so much.